light on this captivating topic. I invite Madam Dr. K. Helen Prabha, Professor and Head of ECE Department, R.M.D. Engineering College, to deliver a welcome note. Ma'am, please, ma'am.
Yes. Good morning, most respected Chairman Sir, Sir R.S. Muniratnam, respected Vice Chairman Sir, Sir R.M. Kishore, beloved Advisor, Dr. M.S. Palanichami, respected Principal, Dr. Anbucharian, beloved Dean, Dr. K.K. Tyagarajan, and especially today's speaker, Mr. R. Sathasivam, Senior Member Technical Staff at AMD, all the parents, various department heads, faculty members, and the students of RMK family. We extend a warm morning greeting to each and everyone present here. It gives me immense pleasure to extend a warm virtual welcome to each of you joining us today for the generic talk on Live Your Dreams. Your presence here underscores our collective commitment to growth, learning, and the pursuit of our dreams, even in the face of challenges. I'm particularly excited about today's speaker, Mr. R. Sathasivam, Senior Member, Technical Staff at AMD Hyderabad, and a distinguished alumnus of our institution from the ECE Department 2007 batch. His journey is not just a story of the personal success, but a testament to the power of resilience and the determination in achieving one's aspiration. In the next hour, Mr. Sathasivam will be sharing his insight, experience, and wisdom on how to navigate the path towards our dreams, even amidst the uncertainties of the life. Let's make the most of this opportunity to engage, learn, and inspire each other. I encourage the student to interact with this speaker and clarify if you have any doubts. So without further delay, let's dive into today's session with enthusiasm and an open mind. Once again, a warm welcome to each of you. Thank you for being a part of this virtual journey with us. Thank you.
Thank you, madam. Before we delve deep into the essence of dreams in this event, I invite Madam Dr. A. Sumaya Begum, Professor of our ECE Department, to introduce the speaker of today's talk to the audiences connected online. Ma'am.
Thank you, sir. A very good morning to one and all present here. It's my honor to introduce our guest of honor, our own distinguished alumni, Mr. Sathasivam from AMD Hyderabad. Mr. Sathasivam graduated in our college in the year 2007. He has an overall experience of 16 plus years. He started his career as a senior embedded hardware engineer in L&T Infotech, Chennai in the year 2007, where he worked for around 5 years. He then joined Arisen Technologies Limited, Chennai, in 2012 as Senior Embedded Hardware Design Engineer. Here, he worked extensively on high-speed board designs, which include power designs, high-speed interfaces, memory interfaces, clock distribution, documentations like HLD, LLD, test plan, etc., bill of materials, schematic design, and layout guidelines. In 2014, he joined HCL Technologies as Technical Lead Hardware Design Engineer and continued there for around 4 years. Currently, he is working as Staff Hardware Development in AMD Hyderabad. He has a very profound knowledge on high-speed analog, digital, and mixed signal circuit design and analysis, jitter, crosstalk, and channel loss budgeting, signal integrity, power integrity analysis, EMI, EMC, ESD, DFM, DFT, DFA, cost analysis, worst case and stress analysis, timing analysis, thermal estimation, power budgeting, power supply design, reliability prediction, FMEA, and root cause analysis. He is familiar with programming languages such as C, C++, VHDL, Verilog, and OS platforms like Linux and Unix. I'm really very happy and honored to welcome our own alumni, Mr. Sathasivam.
Thank you.
Thank you.
Ordinary action. Now I invite our awesome member technical staff AMD Hyderabad to deliver this talk to us. Sir.
Hi, Prabhu. Thank you, ma'am. Thank you, Principal, for the great introduction. about me and my profile. So I think I am audible now. So I will start. Yes. Hello, I am audible.
Yes, sir. Yes, sir.
Oh, I was in
Professor,
mute.
can-
Sorry. Thanks for the great introduction. And I am here to discuss about how to achieve your dreams in the future. So you can go to the presentation mode. So F5.
Now screen is visible, sir.
Yeah, I
Yes,
can
sir.
see
The
Okay.
screen is visible. Please change it to the presentation mode.
presentation mode.
Okay. Okay.
You press F5. Yeah. See, here, still now that 16 years I have worked in that industry. It is because I moved like a many firm like from L&T to now AMD. So it is because of only one secret I am having. That is not secret. I am telling always like whatever the student I am discussing and whatever the people I am discussing, all the people I am telling the same secret, even my own daughter. Okay, that's what I want to discuss here. So you can go to the next slide. So this is you can press again. This is one statement I like it. The real world is much smaller than the imaginary. Imaginary is infinity, but if you're going to a real world, you can find all the things. So it will be like a smaller. So that you have to think like it. It will be like a more complicated than imaginary. You should not think. It will be very simple than the imaginary. So we can go again. But how to enter into that real world. So that is only one formula we should have it. So you can go to the next slide. So we want like some magic wand that will transform your dreams to your life. Okay, so you want to live in your dreams. How to get that magic wand and how to use it and how to protect it. Okay, so those things only we want to discuss in this, and we will discuss some of the electronic future. So electronic future and how that electronic industry is working and what all that division is there. So a little bit 3 slides we can see the last. So here the first thing is what is a magic wand. So what it is, so that you can go to the next slide. So it is nothing but our interest. If you have like a full of interest and keen interest, then you can get the magic wand, so you can start your journey towards like your dreams. So each one we should have that interest, and we should not lose the interest at any point of time. So if you lose any point of time, it will get stuck in any industry, not only in that electronics or my industry, even like college or anywhere, even during your studies also. If you are interested, if you get interest, you will get more information from that one. So go to the next slides. Yeah, how to keep the interest. That's what you need, the curiosity. Curiosity means um, each one you have to dig into more. So what is there inside and how it is working and how to get it, all the things. For here, for example, from my industry, I will tell is whatever I studied from that college. So I like more to go to visit to lab. So most of the time I will visit lab. So because in all our resource in the college, it is very limited because of the money and all the things. But if you go to industry, it will be open to infinity. Okay, so you will get like a lot of the things, like even like that instrument. One instrument will cost like one Ferrari car cost. Okay, so we are driving like a Ferrari car daily. So like this only, I am enjoying that industries. Okay, I was spending like a more time into lab, so that all the concept whatever we studied, so I can able to realize how it will be. That's what the curiosity is driving me. Okay, for that whatever the support things, so we want to learn it. So we don't want to lose our interest, so that we can spend extra time or additional time, so that will be making you enjoy. Okay, so go to the next slide, sir. Yeah, here this that whatever I told, that enjoyment, that's what our return from our spend for that interest as well as a curiosity. The enjoyment is nothing but whenever you are doing like a curiosity and you are learning something from that and you are applying something, and it is working out, so it will give like a more joy. So I enjoyed many of that project and many of that things, all whatever we achieved in the college also. I did like I didn't do any rocket science in that colleges. Okay, small project and some amplifier and other things. I was happy because I know complete of things. So if you're doing like whatever we are doing in the college, it is not like any invention, that we have to keep it in mind. We are doing some prototype, or we are just copying, and we are making it our own. Okay, it is like whatever the letter they are teaching in our school days, like A, R, A, something. Okay, that is not introduced by us. Okay, somebody introduced and we are learning it. That's what we are doing up to the last. Okay, all the times we are learning and we are going. There is nothing called um, finding new. Okay, it is there already. We are getting into our knowledge. That's all. That's a simple thing. So we want to go ahead and we want to learn how it is working and what it is. The understanding only that the world is driving it here. So that's what. If you are making it, if you are getting like a one knowledge, so you have to be more enjoyment. Then you can go further, and you can make it possible anything. Okay, so that's what this enjoyment will keep you that magic wand towards up to the end, or up to infinity, or beyond also. So you have to be very passionate about how to work, and how to get that information from the world to your knowledge, all the things. You have to be tuned it each time. Okay, and one more thing I can tell you, like that financial, if you are focusing only that financial or salary or something, so that that will make sometimes the end card. Okay, that is not a correct way to do that. But if you're doing like a better job, or with a interest or something, so all the way you will get that better salary and a better package, better lifestyle, better life, all the things. So, okay, you have to learn from the world. But that's what here we should know that. You can go to the next slide. Yeah, this is one slide. So because I don't have the time, so that otherwise I will make like a more visibility. So here somewhat understandable. Okay, what is like electronic industry? So here whatever we are you learned from college is nothing but that concepts. So that's what I placed all things in under the root. So you are not crossing the root level. Okay, it is resistance, capacitance, voltage, current, inductance, power, Kirchhoff laws, and a lot of the things. I know that the electronic industry, so I am explaining from that electronic industry level. You can apply these things to any of that department, like computer science and mechanical, chemical, and anything. So, okay, these concepts only you learned from that colleges. So this is a base. Without this concept, you can't make any of the tree. It will get fall down. So you should be strong enough to do that. But the thing is, you should not get fear about how to build that tree. It will automatically grow if you are very good in that concepts. So here, all the concepts, why it is applicable in all things. Here, I am telling that in during the college also, some many things. Okay, I studied some other things only. I understand whatever I didn't get understanding, so I can't study well in that college time. But when I'm going to that real world, so I studied many things. how it is working, and how it will go. For example, for example, when any component like capacitance or inductance, so many things we studied in that characterization and all, we did that lab testing and all things. But when we are using like in that real world, we will have like what I told before is next level of instruments we have. Like using that, we can realize that capacitance and inductance, how it is behaving, and how it will be using the real world. Even like in that many kind of parameter it will come. For example, you studied from that capacitance or inductor. For example, I am taking only two components, not going with a more deep into that one. Here, for it is lead or lag, those things you might studied, and capacitance, what it will do, that properties you study. But if you go into real world, it is you have to consider like many parameters. What are the material you are using, how it will get react to that tolerance level, and the temperature and environment, many things. So you have to test into that one. For example, you are buying like a one car, okay? That will be running in minus temperature also, very high temperature also. So those things they will test in that real industry. For example, when I was working in ACL, they have like a many chambers, like a master chamber, test chamber, and vibration chamber, all the things. Okay, they will test in the. I didn't use much, but I will go and see whenever I get free. I will go and see that. Okay, and that radiation, all things we tested there. Okay, those knowledge and all we will get it. So this is the thing you have to understand, that what is the real world application and how it will be using all the cases. You have to be make understand. That's how you will grow in the next level. So in this component that I mentioned like tree basis like a component. Component is nothing but the real world component, like a transistor, resistor, and inductor, all the things. The inductance and the capacitance is a property, and the components is a things whatever we are using in our circuits and those things. Those things. The circuits as a branch for understanding purpose. I put like this. So using that circuits, we can make like a number of circuits. That's what that application is building. Okay. Whatever the circuits we are using, we are putting together and making like one kind of system. That system can fit into any kind of industry. For example, test and measurement, computers, auto. I provided very few of the industries. Okay, it is there. It is having like a many kind of things. Even if you are going to test and measurement, you can split many. Okay, like our scope, our power measurement, our for example, I think you guys know about stability measurement. For stability, we have like a body and that and all, like a very simple tools we can use. So like this, many kind of instruments we have. If you are going to instrument, another thing, so further it will go to like a probe and other things. Even one probe, it have like a many kind of engineering, how to use it, how to minimize the capacitance, how to use a lossless, and how to probe that without having like a um, because even like a probe, it will give like a lot of unwanted things, like a ghost. We will call it as a ghost. So whether it is a ghost or real signal you are capturing, those things until you want to learn. Each one you have to go into deep more. Then that communication and the computers. Communication is nothing but your back end, and the data center is the future now. So I am our company also working in the data center group, and many companies are focusing on the data center. Previously, many companies were focusing on the IoT kind of things. Now the data center and the industrial is a separate segment, and the ABB, those companies are working in the industrial. Industrial is kind of like robotic things, or high speed controller like this. Okay, it will not go to more high speed, but it will be rugged things for the industrial. And communication and computers, those things are very high speed. Okay, like yes, like a PCI 5 and all, it is coming right now. PCI 6 and all going now. Whenever we are studying like a PCI 2, 2.0, like this, that industry level. Now it is going like anything. One single pair, it will transfer like a 32 Gbps right now. It will go into like more speed. For example, next level is 200 Gbps also it will go. Okay, like a 4 pair, we will achieve like a 200 Gbps. One pair will be 50 Gbps. So that much speed we are achieving. For this and all, like we need to study like a material, and the PCB, those things. Okay, for your level, it is transmission line. The transmission line study is much important to go to this level. So that's what you have to match into each subject to different things. The biomedical is not with the high speed, but it will be like a trustable. Okay, it should not get fail at any time. So that's what it is meant for. And auto also is the same thing. Okay, it should not get failed because different temperature it will go. Even Europe, the same car can sell into our India or in that Arabia. So it will be like a different temperature. It should not get failed, and vibration, those things. So this kind of environment factor also you have to consider into the design, and you have to design. If it is computer, it is very simple. Okay, it will be like a closed environment and AC environment. It will work. So only the temperature matters. Okay, not with that vibration or something. And the consumer electronics is a different kind of things are there, like a mobile and uh, these like whatever the gadget, PlayStation and those things. So it is like a consumer, all the electronics we can make. So there is no place without electronics. Okay, so all the place we can find the electronics. So it will be like this only. All then that if you want anything to explain more, so we can go into tip, otherwise we can go to the next slide. So here, the future trends in electronics, I was mentioning here, this is I got from that few sites, and it is like a very top level only, not very deep. So you can go to the next, click one and percentage will come. Yeah, you can see that advanced electronic materials, that is a 80, that how much occupation in that overall industry, the percentage wise I have provided here. So like organic industry, organic electronics, the future organic electronics creating like a 17% in the future. Okay, so that main now that focus area, I think you guys heard artificial intelligence. So that is a 13%. That is a more important thing. The previous thing was like a Internet of Things. Internet of Things is like all the gadgets now. Even washing machine having camera. We don't know why it is required. But these things and all like evolved recently, and these things are dominating more. Okay, Internet of Things and artificial intelligent creating impact in all the gadgets, whatever mobile, laptop, data centers or something. For example, here only one explanation I can give. Artificial intelligence is creating like a more impact now as well as in the future. You know that the chat GPT, so how it is working, all things, it will get like a more training. So you need like more processing capability and more speed, all things. How we can achieve this? So nothing but we need that like a high speed processing unit as well as memory because it need like a more data it should handle whenever it is required, like it should get that particular data with the high speed. That's what that artificial intelligence is doing. For hardware wise, we have to achieve like a very simple manner and with a low power. So that's what like electronic industry is doing. So in the artificial intelligence, first guy is NVIDIA. Now he is dominating more um, unit because you guys know about the processor is making with the Intel and AMD, but graphics processor is made with NVIDIA. When that cryptocurrency is getting like a evolved, that time they want like a more processing speed, so that they choose like a different than the processor, that nothing but graphics processor. So they are using like graphics. That time it growth like anything, it got growth like anything, that NVIDIA. So they are dominating. Now the AMD also getting dominating. These two guys are playing more role in that AI processor right now. And the AMD and the Qualcomm is nothing but um, mobile processor thing. They are also introducing little bit AI into that one. So that will be in the future right now. But it may get changed. This is a transition period. We don't know how it will get evolved and other things. But all the core areas, it will be useful. Okay, without anything, even like a sensor or like output device, we can't do any of the intelligent. Okay, it will be, but that percentage of contribution will be less. Then embedded system. Embedded system is nothing but whatever we are doing is called like a embedded system only. It is categorized kind of central processing unit. Even like a car, we are having like a CPU or something that also called like embedded unit, embedded systems, but it will be different segment. We have to create like a different norms. Even like aero industry, we have like a different standards. So I went to across like aero industry somewhat who is working. So I seen that what are the things. So it will have like a failure failure redundancy. So if it even like it should not get fire first of all, and it should get like immediately any fire or anything or any failure, it should have like a redundant thing like a stepney. Okay, so like this that system will work. But our mobile and all, so no safety, nothing. Okay, it should work like this. So like this, that electronics complexity will go as per the industry. So that printed electronics, nothing but our flex or something. Okay, so those things, printed things, and advanced IC packaging, miniaturized electronics. The miniaturized electronics, you guys already looked into that wearable watch and Google specs, those things. That is what the miniaturized electronics. So 3D printing, 3D printing also it is creating like a many impact in our world. Part of the, for example, the Tesla car, because the design, it is due to that it is achievable due to 3D printing. But all others are the sheet kind of metal. That is, we have to cut the sheet and you have to press and we have to make the design. That will be somewhat complex. That's why those guys can't achieve like a Tesla kind of design. Okay, 3D printing may make more in the future. Okay, but now in that small things they are making like a 3D printing. Even like our um, uh, internal organs or something we want to change, you are using like a 3D printing. Immersive technology, that is the next level. So that is very little. So this is how that future will be. Okay, so you can go to the next one. Yeah, here I provided what are the divisions are there, and okay, here electronics and communication and that electrical and electronics, both department can go into any kind of this one. So because they don't want to be expert in RF, and you can't be expert in RF, but you have like one subject from the RF. But after going to the industry, even like after 5 years also, you can choose your path. Okay, so which area you like, you can go into that. It is having an I provided very few here. Okay, analog means audio and RF, even like analog video is there, analog signal is there, many things are there. Okay, in analog, if you are going to analog, so same thing like whatever I told here, um, analog things. So it is have two perspective like IC and board level. So both you have to touch. But IC level, like many dedicated expert will go into that things like analog expert only they will go. But in the board level, you have to handle like a digital analog in the both in the same board. But that is not like a more complex things. Because why in the ASIC level means you have to be very much familiar about analog circuits. So that will be like a more complex in that IC level. I think now they are going with 5 nanometer also. Okay, I think even they are going into next level. It is reducing day by day, so it will be more complex in the future. Then optics. Optic is nothing but optical electronics, so that all the high speed interfaces going with the optical, especially for the networking. And you know that in home it is coming like a optical fiber. Even like a data centers, one data center to another data center, it will go to that optics communication, because it don't have that distraction and other things. So it will be very easy. Previously, whenever I studied, that time that optical is more costlier. Now that optical is cheaper because of that industry evolving. They are making like a very cost-effective product right now. Then that power and control. Power and control, it is nothing but any kind of like robotics or high kind of high level industries like a motor or something. We need that power and controls. Okay, that is okay for a small things, whatever you are using like a day-to-day life. Previously, you might see that regulators, that is a resistor-based things. Now, after that, the FET-based or ACR-based regulator came for that fan. That is nothing but it is whenever we want, we'll give like a pulse. It will give. Okay, when you are doing like average, that overall power will be get reducing. So on time and off time ratio, you have to play with that one. So those things, it will be like in high power motors and all they are using now. So that is a high power device and all things it will be using there, like handling like high current also. Okay, that is high current is a high current as well as high voltage. Okay, so this is a distribution, high voltage and high power distribution. That is nothing but our generation and distribution field. So those things they are calling it. This is a purely like electrical as well as electronics is there. Okay, that will be part of that. The digital industry. Digital is nothing but embedded system. Whatever I am doing, I am involving those things. That is called like a digital industry. Even like it will have like analog part also, but that is very minimum. Like for sensor or those things only they will use analog. Embedded system, nothing but any kind of like a processor or processing capability or networking or anything. We can call it as a embedded systems. Even like server or motherboards, those things also call it as embedded systems. So then the complex logic. This is what that player for Ultra and Xilinx was there. Now Ultra is acquired by Intel and Xilinx was acquired by AMD. So those guys are doing like a FPGA and a CPLD, etc. And even like other players also there, like latex and those things. They are using like a CPLD kind of thing, like a little bit fast FPGA. Now this FPGA is going like a next level. So you can go to that AMD site and you can see that FPGA, how it will be evolving. Okay. It is having like a processor kind of thing as well as that hardware acceleration point of view, so that it will provide like a more processing capability, even like that FPGA having like a AI engine into that one, so that whatever that application you can use for AI or more fast, for example, encoding or decoding, these things and all, if you are doing like a hardware level, it will be very slow. Okay, if you're doing in the hardware acceleration, if it, for example, for hardware alone, okay, uh, for encoding alone, we have like a separate hardware that will be more faster than that software passing. For this, I can give you one small example. If it is any Android phone, you can see that they are going with 8 GB memory and something, okay, more than that, 8 GB, 4 GB like this. But if you're going like an Apple iPhone, they will have like a very small memory. Okay, how they can achieve these things? Also, that it is taking like a more less power only when compared to this memory. Okay, this is what that electronic evolving. So that is nothing but they are using like a co-processor. Now hereafter that all the even like other brands also, they are bringing those concepts. They are taking that concept and they are building it. The processor is nothing but the few applications they will use that separate processor. Okay, the same technology they are using in the chip level. Okay, each for each that hardware, each application by specific purposes they will use like a hardware acceleration unit. So even like audio, video, and even encoding and decoding. For example, for video, it is MPEG decoding or so those things and all. They can use like a separate codec and those things with the die level itself. Okay, that will be creating like a more faster than the processor. So that OS and other things should not get bothered. So and the VLSI and the ASIC design, that is a separate industry. Most of the things, whatever I am working, I am kind of like a board level engineer. So, but here major employees are VLSI and ASIC design in the ASIC level. Okay. Here I will give you one thing is now latest yesterday news. I think we might go into that more deep into that if you are watching like a news or something. Micron, you know that memory manufacturer. The lead memory manufacturer leader is Micron. Okay, all the our processor memory, chip memory, or mobile memory, or laptop, or computer, anything, they are the manufacturer. Okay, they are having like a R&D and more than 3,000 employees working in that Hyderabad. And these guys are planning to start one industry in that Gujarat something. Okay, so they want to do the manufacturing here. So this is the future now, because due to the Corona time, many countries try to move to other industry also, because they are suffering with that production. Okay, like many things are delayed, computers, cars, and all things due to the chip shortage. So that they want to manufacturing in different location. Now many manufacturing industries coming to India. It is due to that this kind of like a environment. So it is having like a more opportunity. It is opening like a more opportunity. But the industry is, I can tell you like it is kind of industry work is different and R&D work is different. Whoever want like industry work, they can go for it. You have to choose according to that. Okay. Then that computing is nothing but a any kind of thing like a small processor, from the small processor to server processor, anything is a computing. So and then instrumentation is a little bit industry. So that is it's mainly in that industrial it will use mostly. So but it is not having like a more area in that India, like a very little company only playing here. And the communication is like a RF level as well as like a digital processing level. Okay, both it will be there. Like even like now the 5G is coming, previously 4G. Um, and before like a CDMA was ruling the world, the future we don't know. Okay, so the communication is much important. So this will be stand for long. And mixed signal. Mixed signal is a digital signal processing. So that is nothing but it will be playing a role in many kind of divisions. For example, audio, video, even like communication RF. So they will have like a DSPs. Okay, so it this under like for example your field selection. Okay, many companies will have this kind of opportunities. Okay, so if you're good in that signal processing, you can go into that one. But that selecting that division is not with your hand, but you have to select that company, then you have to work accordingly. There you have to select. Okay, this kind of divisions under. Then the electromechanical. Electromechanical is nothing but like okay. For example, in that car, I can tell small example. In the fuel injection and all, like it is electromechanical. Now all the things are like a electronic control only. Previously, it is not electronic control. Okay, now all the things like a electronic control. Like a small thing for automatic car. Okay, automatic car or yeah, it will be like a electronic control. Even like nowadays, ADAS is coming. Okay, for the ADAS, it will have like a fuel injection. It should control like a fuel injection automatically, so that it should have that processor unit. It should take the decision where to control, how to control, and when to control. Okay, those things and all, and how much those point of view. And the gear change also it will do. How it will do? It's require like a power. Okay, so the power means it should not make like a small mechanical relay and all. So it should have like a hydraulic, so that the motor will pump that hydraulic and it will do. Many sensor it will play like a proper changing. Okay, so here that hydraulic control will be controlled by the motors, and those motors is driving by the electronics uh, controller. Okay, so these things under like a call it as a electromechanical. And even like a small relay also there, and a solenoid is there. Those things under like electromechanical industry. I told very little bit, less than 1% only here. So if you are to dig into that, you get like a more information about each industries. Okay. So yeah, you can go to the next slide. Yeah, thank you. Here you can click that one moment. See, this is what I want to tell you. To world's best teacher is nothing but your world only. Okay, this is a starting for you. So this is not end. Okay, college is not end. Okay, college is just they prepare you, they make you like a next level for the gate. So here you have to learn yourself. Okay, because I struggled initially because that R.M.D teaching like more more concept and other things, because I never studied myself try to study, but that will be tough for me. So after that I make that a habit to learn myself. Okay, so because that is good, even when we are coming like a very play level things, and it will be very good to make to understand something, but after that you have to learn yourself. That's what I want to try to tell you. So you dig more into that and start learning yourself. Okay, that will be teach you like many things, and it will be help to achieve many things. And don't forget to keep your interest for the next level. That's all. Any questions? Hello?
Yes, sir.
Any questions?
Participants-
We can go with the questions for 5 to 10 minutes. Anything if you want. Yes. You can ask like any industry because when you are working in that education level, so that industry level is different. Whatever that transition or something, or see even like a technical level, if you want like any query, you can request now. It's possible I can answer.
Participants can post your questions even in the live chat in the YouTube.
Even staff also can ask questions if you have any queries. So that will be helpful for the students.
Sir, can you explain about the immersive technology that you have mentioned in the slide?
Yeah, that is also new to me. Because I was working in that digital and those things, okay, digital embedded and ASIC level. ASIC level, I know what is happening, but I didn't work much. Okay, I can tell you. Wait. And whatever whatever I am working, so I can explain little bit things. Then I will go to that immersive. So what I am doing, I will tell you small things. Okay. See, initially that you know that schematic is nothing but a circuit level. So those things and all we can make. The schematic is coming from the requirement phase. So from the requirement, we will get that any kind of like a requirement. For example, if you want to make like a one car infotainment, if you want to make like a one networking backup or those things. So what are the things are required? So what are the input speed, bandwidth, and output speed bandwidth? What are the things are required? So we want to make it. Okay. So which component we have to use? All things we have to shortlist. So this is what the requirement to that design level, architecture level phase. Okay, that is a one phase. Then that after the architecture phase, if it is freezed all the things, we want to finalize like each component. This will be like a very long process. Okay, after that component, so we want to go into that schematic level. Okay, the schematic once finished, the next level is a PCB. So here all the things, whatever the theory we studied, all things will get involved. So for those things, that SA and PA will get help. Signal integrity and power integrity, those things are helping. So these things also you can little bit introduction. We can start from that college level also if it is possible. So they can understand something. After that, the PCB, it is manufacturing is going, manufacturing nothing but a fabrication, they will call it as a PCB fabrication. Then that assembly, the PCB fabrication mostly happening in that China or US or even India, like a low level. So the PCB is a multiple layer, even like 32 layer also nowadays they are doing it. Okay, that much complex PCB. Most of the guys here are doing like a more majorly 8 or something. So whatever the high speed or those things, the 8 level. I think in the study level, I can tell you one more word like strip line and micro strip line and all we studied majorly because we don't know those things and all play major role in that PCB. Then after PCB, that assembly component will get assembled. That is having like many assembly lines, even like a China having like more assembly lines than our India. So after that, we have to test it. We have to do the DVT, design and validation test. Then we have to go into that environmental test like a ESG and those things. Finally, we will use like a quality test. Quality test is like a same kind of environment with a different temperature and other things. We will use it. This is a complete process of electronic industry. The immersive technology. So we have to go into deep more because that is new to me. That's why I didn't go into more. I have to check it more. even that electromechanical and all, like a basic level only, I know that. This digital and FPGA, those things and all, I played much. And one more thing I want to tell you is in that FPGA, okay, you can go to AMD and there is tool called Vivado. I think previously, whenever I study like a IC something, integrated environment something. Okay, now it is called like a Vivado. That tool is giving like a more input about how to build like a structure, because nowadays I think when I was there, we were playing with some of the tool kind of thing, PSAC or something, with our professor, Professor Chandrasekhar. That time it was like building with that module kind of thing. Okay, so that is very small level sensor and those things. But now these things and all, even like you can create like a very high level things using like a model block diagram design. Okay, you can play into that one. So how that system will work, not very deep level coding and all. You can create like a block, it will do automatically. So those tool and all you can get into hands on. So that will be having like a more future things. They are putting more effect into those kind of tools. But because Ultra procured with Intel, so they stopped somewhat a limit, and now they spin off so that they want to get growth into the same industry. But here their growth is much better. Okay, that under like you can have like hands on those things.
Sir, there is a question from one Mr. Chandrasekharan Subramaniam,
Yeah.
and he was asking about AA hardware. Can you brief about AA hardware?
Okay. Yeah. Already I mentioned something. AA hardware is nothing but see, we need that more processing capability. That more processing is happening from that, not with the normal processor. It is with that these things. GPU, okay, graphics processor unit. The graphics processor unit can handle like a very fast unit because I told hardware acceleration. This is a much important for that AI, because each purpose, if even like it will be application specific also. If you're going like a very specific with a video or audio, only that audio encoder or video encoder or audio video processor things, we need that separate die. Okay, those things. That normal AI processor will have like a number of hardware accelerator into that one. Okay, you can utilize those things so that it will not give like a burden to the software. That is one thing. Okay, the how speed up the processing. That is one thing you have to take care in that AI processor. Next thing is a memory. I think in the computer architecture, if you take that, there is a different kind of memory. One is like a cache memory. Next thing, and the next thing is a processor memory. Next thing is a hard disk. Hard disk is nothing but a storage only, like a OS and all. It will run into that one. Next level memory, it will store into our normal memory. Okay, then if you need like a fast, then it will use a cache. The cache is nothing but a 12 MB or something only was there in the previous. Now the AI processor, it is nothing but a cache is integrated into processor also. That memory, that whatever the memory we told, no, that DDR kind of like DDR4, DDR5, those things integrated into chip level itself. Okay, that's what now it is using. That is, we can call it as kind of like a hybrid 3D stack. Okay, that is even if you're going like a package, it will have like a number of things we want to come into. The 3D stack is chip above the chip they will use. Okay, so that much fast it will give. If you're making like a length, that bandwidth speed will get reduced because of the losses. If you're making like a short, it will reduce as it will reduce the losses and it will make like a more fast. So that memory, for example, you can check with AMD site, you can NVIDIA, those things will have like a hardware processor. So you can get into more information also. For us, it will be like for college level, it will be more information. So they will have like architecture and how it is working, what are the blocks it is having, all things. So the memory is more important into that. Next thing is the power. Power, it will not take like a more power. It will be using like a very less power. Then only we can having like a very good things, because nowadays you know that data center is creating like a more impact in our world. Lot of data center in that Texas and those places and all, they are using like a solar power. But India also they are putting it. I don't know what and all they are using it, but they are planning to build more data center in India nowadays. So we will get the shortage in the power because one board itself will get like 1,000 watts, means it will be huge power. Okay, so those things also will play into that. Next thing is uh, that external world communication. Processing power we introduced, and memory we introduced. How to feed the data and how to get the data. Okay, that is the next level. Okay, so that is nothing but for whatever the standard you guys studying, like PCI. Okay, the PCI creating like a more impact in the world. Now the PCI going like a five already came into picture, and 6 is going. 5 itself like a 32 GBs per differential LAN. So like this, it will have like a 16, means you can think 16 into 32 GBs, that much it will do. The next thing is the QSFP. The QSFP is nothing but a optical. Whatever we discussed, it is optical. So optical wise, they will interface that optical. One port, one cable will go into like a 200 Gbps something. Okay, so that much speed it will. Like this, it will have like a many port. So this kind of interface you have to provide. This is what it is making like a process, that hardware creating like a much powerful. Okay, hardware. So as a hardware, they are providing like all the input bandwidth and more output bandwidth, then processing power and memory. So then the software they can use for any purposes, for training and all things, AI training and all things. They can use the memory, whatever it want. If you want like an external world, they will connect with the more bandwidth. That also provided by that optical and PCI, those things. And this is the one thing. So you want to make like a multiple. That's what that AI coming into picture. Previously, the two processor, okay, that and all very rare in that previous things. Now parallel processing, okay, it is more common in the world. For example, even like okay, that industrial things, they will use like AMC, those things and all. AMC nothing but slot card. Okay, you can insert the card, you can remove the card. That is each card having like a same kind of processor. It will have like a output or input bandwidth separate path, and processor to processor communication separate path. That is more important in that AI. Now up to 8 or something. Like recently, Lisa also introduced, our CEO introduced one of the things. You can, if you're having the time, you can watch that video. You will get into, you will get more information about those things. Okay, so how it will do is, if you are, for example, 2 or 3 or 4, okay, each processor having like a dedicated interface to communicate with each, so that it will share the load among that. Okay, so that it will take that processing to the next level. Okay, this is how the day is working on. So thing is memory, processing capability, and parallel processing. For example, sharing the load. Okay, those things. Okay, then high bandwidth input and output connection. These are much important for the AI hardware. So this is a basic level I told. It is very, very basic level. Even like who are not there in the electronic industry also, they can understand. That's all this input. If you want like a more input, like as a like many purposes, you can go into that site. You can get more information about these things. Okay. It is having a lot of
Thank you,
open
sir.
source things.
Thank you, sir. Is there any other
Yeah.
question?
Sir, my voice is audible?
Yes, sir.
Yes, sir. Hi, Sathasivam, sir. I'm Arul, assistant professor at R.M.D College.
Yeah.
So, just now we started the VLSI specialization in our department. So,
Okay.
still, even though we have introduced the VLSI, we are in basic level only.
Okay.
So, how to know that the requirements of VLSI industry, because the engineering the 4 years, right? So, whatever the teaching in the 4 years, that will be absoluted after 4 years. So, how to know that requirements of engineering courses are 4 years, right?
Okay.
Yeah. So we are training only on we are putting training on the Villa Vestier. And
Okay.
just now we are entering into the training Vivado. But still we are not learned completely the Vivado, but industry recently introduced that VTs.
Okay.
How the institutions are cope up with that industry, that fast change?
Okay, because I'm not into VLSI more, but I am near to that department. So I know something. I will tell you that VLSI, the Verilog HDL is now running like a VHL now, running out of state. That system Verilog is going more into that future. Okay, because the Verilog, okay, for example, like a Verilog VHDL, we can compare with that embedded C kind of thing, like a basic C level. And the next level C is like a Verilog HDL. I'm giving like a top level things because I know few of things. That system Verilog is kind of like a C++, that objective oriented, and it have like a many advantage for them. And they are going with the system Verilog, the language wise. But in that that Vado. Vado is nothing but it will have like a little bit coding because all the codings are ready to available now. And if you are selecting like one block, it will have like things you have to configure like a GUI level. Okay, you have to configure what are the inputs you have to feed into that, and you have to use it in your design. So after you are creating like a one compilation or something, it will generate automatically all the coding. Okay, you can see that. And you can see that RTL placement, then that power level and all the things after that synthesis and all the processor, all the steps if you are completing, no, you can visible all the things. Then the next thing is Vitus. Vitus is a one more tool. So you can see that one. So that is having, you can check that. It is available, student license, you can use it. So that is, most of the things are embedded. So C++, those things. It is not like a Verilog or something. That's what the thing is. Okay. If you are doing like a ASIC design, okay, you need only Verilog and VHDL. If you are using your ASIC to your application, the most guys preferable is embedded C or C++, those things, not with Verilog. That's why the Xilinx is transition from these things to embedded C. So they are introducing that also. You can using that one. For example, all the embedded engineer only using their chip, that kind of like a next level FPGAs. So they want to utilize with this kind of like a software. Okay. So they are going to Vitus now. Okay. Both the tool, it will be useful. So if you're mostly part of that ASIC design, then you can live with Verilog on the system level. If you are utilizing like a chip and you are using some application, then you want to go with that C++. And apart from Verilog. So because we can't decide that which guys is going to that deep into this one or C. So they want to touch up all the things. Then when they are going, they can select their stream.
Thank you, sir. We have two more questions. The first one is, how can I start
Yeah.
experimenting with electronics without feeling overwhelmed? Since certain electronics are costly to afford, are there local workshops or maker spaces where I can get hands-on experience?
Okay. The first thing, whatever you want, touch upon that electronics is so okay. First simple thing is whenever I joined as I joined in that I think R.M.D college, I attended that campus interview from that things. The first question, whatever he asked is how to glow that LED. Okay, that itself that many of that BE guys can't answer it. So I answered, I got selected. Okay, that's the first thing. Okay, electronics is don't want to go into very advanced level. If you are taking like a very Arduino board itself, okay, so we should know about what is a voltage, what is a current. Those difference itself people don't know. Okay, so this is the basic things we are lagging in. So we want to start that one. So people are thinking like we want to provide like how much current we want to provide. It is not like this. So how much current it won't take, it will take. It is not having the limitation. So if it is having limitation, it will cut and it will reduce the voltage to maintain the power. So those things and all, if you're doing that experiment only, you will get no. This kind of experiment, we need that simple power supply. Okay, simple things like for example, if you're doing like a FET, the characterization we are doing, even that characterization, the next level we can do with the FET, and we can use in the some circuit, some application we can use. We have to probe each one. We want to see that what is happening. Okay, we don't want to go like a very advanced thing. and all things like even like colleges also. I'm having one point for the colleges. They are all are like expecting the students should do like immediately AI. Okay, immediately like one kind of like a rocket science. Not like this. Whatever your experiment is there, if they are able to build, that is enough for the student. That's what I told. Students are expecting at the root level only. So not with the STEM or something. Even they are not going to the component. And the next thing is there's lot of simulation tools are available. You have to try to, for example, I will tell you one thing is LT Spice. I think that is a free of cost. Even when I was in diploma before B also, I used that LT Spice. So that will give you like a many idea because you told no that instruments are very much costly. So the tool is simply it will provide like things. And one more tool is Falstead. Falstead, one site is there. Okay, one professor built this one. So if you go that, you can build a small transfer. For example, you are teaching like a how that integrator is behaving, how the capacitor is behaving, lead or lag circuit. If you are applying like a sine wave, how it will go. Okay, so those things and all, it will give you like a clear idea. So visually, if you are see anything, it will be like memorable. So if you are teaching in that text level, it will not be good. So animation or visual. Nowadays, like it is growing like anything. So we want to see that kind of like animation or those things. That is enough for the college period. If some guys going to the next level, they understand all things. They want to build some system. Okay, they can build their own. No need to go to anything, but that if you are going with 500 megahertz or something, okay, less than that only mostly, then that your college scope itself enough. Maybe 100 megahertz or something, the college scope is enough. If you're going with, for example, kind of like our things, we will go with a 25 gigahertz scope for DDR and those things. We want to validate what is happening exactly, those things. Even our guys also will do the mistake, the connecting the probe to that real end. Okay, that will have a number of things. How to connect the probe also it will be matter, so that the learning and how you are changing yourself as per the feedback, that is what more important in the future. Then only, even if you are getting like a ferry car, you can handle. So basic concept you have to know. Okay, so like for driving, they have to tell out how that transmission is working, how that engine is working, operating. Then only you can handle the engine perfectly. Otherwise, something ghost is there inside, and if you click that accelerator, it will go like this. If you're thinking, definitely it will be the problem. My advice is like a smaller thing. You can start with the breadboard, and you can use like a even like you are pairing with that some component, even like a 100 rupees component. You are pairing it will get burst. You try with that first simulator, then go with that real circuit, then do that. We bought many things. So it will be like a common in that electronics. Even like when I was diploma, I tried like many things. I burned many things. I have more freedom there because I have more time there. But here it is reduced. Time is reduced because of the B and the curriculum and all the things. I never tried the experiments much, but in home also I never tried the experiment in when I was in B. Then when I going to industry, I tried many things. But diploma, I was trying many things. Okay, okay, whatever I played, I don't have much knowledge about the processor and those things. I played like a analog device, analog circuits like amplifier, whatever our usage. Okay, like amplifier. The building amplifier is not easy like whatever we are thinking. Okay, our guys doing projects in very advanced level, but if you are asking to build that amplifier itself, it will not be so much easy because it will have like a lot of problem in the connectivity wise. I told no what wire you have to use, that impedance, throughout impedance you have to maintain, whatever theoretical already they know that, but where to apply, that's what they need it. So audio from year to year, you have to maintain that impedance. If it is small impedance mismatch also, it will give like a reflection. That reflection make like a hell. So and power you have to filter it. We should not have any power noise. So you have to filter properly with the proper capacitance and diodes and you have to use. Then you have to provide to that. If it is any noise, it will make like a humming noise or something. So those things only we have to get. These things only that the industry is expecting. Okay, not like even like our interviews and other things also. Even I came to R.M.D for one interview from the ACL. I asked like this only, okay, small kind of things only. So that's what we need it. Industry will teach more after that. The whoever want
Thank
like
you, sir.
experiment, they can go with they can go with that simulator first. I told LTE, LTC that acquired by analog device now. Even the tool is available. The free tool is available. You can try to utilize like LTC, that linear technology, that LT Spice, that is called LT Spice. The Spice simulator is that is licensed. Okay, Spice simulator, many things are there. That under license, it will be simulator also more costly like instrument nowadays. Okay, so this kind of like a free tool, that is enough for the college students. Like whoever want like a next level build, they have like a number of support. They can get like industry contact or something. They can go into that and they can build it. That is possible.
There is one last question. After that, we can close the session. The question is, will quantum processing unit come under electronics technology, electronics and IC technology?
Okay. Yeah, this question we also raised long back in that our CEO lesson. So see, this quantum processing is still under that study level only. It is not coming into that industry, because I am also don't know much about these things. I heard like this only. So this quantum is evolving only. So it is not coming into real world testing. So it will be ASIC level designing only, maybe. I'm not sure about this one. So you can search more into that one. Yeah, my advice is that student, they should not go to that next level. Okay, they should whatever I told. Okay, you are in that root level, so don't you. I am not telling like a don't try, but that taking like a fruit directly, that is harmful. Okay, that is not that will not be like a organic thing. It will be like a making like a skipping like a many steps. Okay, the basic things only we need it. That's what I believe it. Okay, so the whatever they studied, they have to be 100% sure about the concepts. Even I told that small things are like a voltage and the current. That basic concept itself, many guys didn't know. Even like experienced guy don't know. In the interview level, we seen that is don't know. Okay, that's what we need to make like a more strong. The quantum level, the quantum things, still it is like a research level only. Like it is not implemented. Like how to implement those things and all, we don't know. Because the thing is, industry having like a lot of restriction. The theoretical is different and the industrial is different. How they want is with the less cost, they want to make it. And what, okay, so small thing they will tell. If you are making anything, okay, that should be affordable for that technology. If you are making anything for the uh, farmer to use it, you should not make that cost as a 2 crore. Like this, that industry is expecting. Okay, when the cost is increasing, I told whenever that optical was introduced and we were studying that optical, that time that optical is costly. Now each home is having like optical cable is very cheaper now. That time optical cable is much better, much costly. So like this it will get evolved, but now still now it is not coming into that picture like a real world applications. Mostly it will be ASIC. Yeah.
Okay, thank you, sir. Thank you, sir. That was a wonderful delivery of the content. As we draw the curtains on this enchanting afternoon, let us carry forth the flame of inspiration ignited within our hearts. Let us dare to dream, defy the odds, and carve our own destiny. Now, I invite Mr. V.S. Prabhu, Assistant Professor of ECE, to deliver vote of thanks for today's event. Over to you, Mr. Prabhu.
Thank you, sir. I would like to thank Thiru R.S. Muniratnam and Vice Chairman Thiru R.M. Kishore and the entire management team for giving us the opportunity to organize such a wonderful session. Next, I would like to thank our advisor, Dr. M.S. Palanichami, and then our principal, Dr. N. Anbuchelian, and our dean, Dr. K.K. Tyagarajan, sir, for their consistent support and guidance. On behalf of R.M.D. College, I would like to extend our heartfelt gratitude to Mr. Sathasivam for sharing such an inspiring and insightful talk on Live Your Dream. We have been reminded of the importance of daring to dream, of embracing challenges as opportunities. Next, I'd like to thank parents. Hope it was useful for you to know about your children's dream and opportunities. Then I'd like to thank our HOD, Dr. K. Kalanprabha ma'am, and various department heads. Next, I would like to thank of all our faculty members who are the real transformers of technology. Last but not the least, I'd like to thank all the young and dynamic student of our RMK family for joining and making the session meaningful. Hope it was useful to live your dream. Thank you.
Thank you, sir.
Thank you.
Thank you.
Thank you all. Have a good time.
Thank you. Thank you very much for the opportunities.
Thank you, sir.
Yeah.